We carry a silent conviction deep within our intuition, a certainty forged by years of seeing things fall. A cup slips, a set of keys drops, a journal slides from a desk. The ground is always there to meet them. This rhythmic repetition conditions us to ignore the mechanics. Gravity becomes a mere label for a familiar sensation, as intuitive as moving our fingers. But discomfort is actually a deceptive mental shortcut where habit replaces genuine insight. To truly grasp gravity, we must discard our assumptions. We must return to the basics, recounting only our direct observations while rejecting convenient explanations. Let us start with a basic physical act. Suspend any object, keep it perfectly stationary, let go. It starts moving gradually at first, then picks up velocity in a continuous smooth flow. The rate of change in its travel, its acceleration is constant. Now repeat this with a different item, something bulkier, more solid, heavier in your hand. Release it. Monitor its shifting motion. It does not change in a similar fashion or an approximate way. It changes with absolute, identical precision. This is our foundational reality, yet it immediately clashes with our gut feelings. Ask a stranger without giving them time to ponder which lands sooner, a lead weight or a bird's plume. Their instinct, the memory in their tendons, suggests the heavy weight. However, a rigorous trial delivers a different verdict. The plume only wavers because of atmospheric resistance. Pump out the gas, create a void, and that plume descends in perfect synchronization with the lead. So we record the data without embellishment. Near our planet, when starting from stillness, every object experiences the exact same shift in motion. This isn't a hypothesis, it is a clinical report. Pause for a second to acknowledge how bizarre this is. This trait is completely solitary. In almost every other physical event, the makeup of the object dictates the outcome. Strike a heavy ball and a light ball with equal power. Their reactions differ. Gravity is the only force that never asks what you are made of. Apply heat, they warm at varying speeds. Give them an electric charge, their responses diverge. But gravity remains indifferent. It never audits the material. It enforces the same kinetic law on a speck of sand and a grand piano alike. This lack of bias isn't just a metaphor. It is a physical signature, a unique trait that isolates gravity from everything else. Our standard phrases, like gravity pulls things down, fall apart under minimal logic. Iset is a fabolo range, my donware a babo, with the houses a port under minimal logic. For someone in Tokyo, down is also toward the center. Their directions of down are nearly poles apart. Therefore, gravity isn't a downward vector. It is a pull toward the Earth's bulk. Yet even the concept of mass is elusive. If a larger mass triggers a more intense pull, why don't heavy things accelerate faster? They don't. This muddle comes from blurring two separate concepts. One is the intensity of the gravitational grip. The other is how much an object fights a change in its state, its inertia. These are distinct functions. Yet, in a harmony so exact it seems planned, data shows they are dictated by the same value, the object's mass. The variable defining the pull is identical to the variable defining the resistance. Because they are equal, they negate each other. This balance is why all matter descends at the same rate. We don't justify this symmetry, we recognize it as a fundamental rule of nature's accounting. Now, let us pivot from falling fruit to the orbiting moon. This feels like a separate riddle, but apply that same precise scrutiny. Imagine the moon suddenly losing all its lateral velocity. It would drop straight toward us. Now return that sideways momentum. As it drops inward, it also travels across. So it bypasses the Earth. Provided the correct amount of sideways speed, it continues to miss, falling endlessly in a recursive loop. The moon isn't held up by a cosmic tether. It is in a state of eternal, graceful descent. The same principle guiding a plummeting stone also guides the lunar arc. This is a massive conceptual merger, but it prompts a specific inquiry. If the effect of gravity is identical for everything in one spot, why is the pull weaker on a mountaintop than in a valley? Separation is the key. Not in a vague sense, but with geometric precision. Track the falling bodies, map the orbits, chart the change in velocity against the distance from the center. You discover a rigid pattern. If you increase the distance twofold, the impact drops by 4. Triple it, and it fades by 9. We can visualize this logic through a simple distribution model. Think of the influence radiating from the planet as being spread over an invisible bubble. As you expand to a wider bubble further out, That identical total influence must cover a larger surface. The surface of a sphere expands with the square of its width. Consequently, the intensity per unit of area drops as the square of that distance. This isn't a hidden mechanism, it is a spatial requirement if our world is three-dimensional. We verify this rule on lunar paths, planetary orbits, and deep space probes. It stands. If our planet generates this, can other matter? We must verify. Take two massive lead cylinders in a laboratory, hung with extreme care to negate outside noise. Move them close. They shift nearly invisibly, yet undeniably toward one another. Gravity isn't a planetary monopoly. Every bit of mass draws every other bit. The rule is reciprocal. The fruit falls to the dirt, and the planet imperceptibly rises toward the fruit. In a pair of equal weights, they move toward their shared center. This isn't philosophy, it is essential for the conservation of energy. We have constructed a descriptive map. Gravity imparts the same motion change to all items in a specific location. Its power fades with distance in a geometric ratio. All mass participates. This allows us to forecast a vast range of events. Yet this force model starts to crack when we investigate further. Consider a clear logical test. You are trapped in a dark elevator. Wait! Items drop to the floor. Now move this elevator to the deep void where no gravity exists. Fix the engine to the base and ignite it, accelerating at 988 meters per second squared. Inside, you feel weight again. No test performed inside that box can distinguish between resting in a gravity field and accelerating through the void. This is the equivalence principle. Gravity and acceleration are identical. This isn't a gimmick, it is the ultimate clue. Track the logic. Fire a laser sideways across that accelerating elevator. By the time the light hits the far side, the wall has shifted upward. To an observer inside, the light beam seems to curve downward. If acceleration equals gravity, then light must curve in a gravitational field too. This is a forecast, not a guess. We checked. Light from stars passing the sun is indeed diverted. The theory is proven. This destroys the old force model. A force acts on mass, on something that resists. Light has no mass, yet it bends. Gravity, then, cannot be a standard force. It is doing something deeper. It is warping the very stage where everything matter and light alike exists. The mystery intensifies inside a falling box. Drop it into a gravitational field. You become weightless. Released objects don't fall to the floor, they drift. Gravity vanishes. You are simply following a natural trajectory. Gravity, therefore, isn't something you experience while falling. You feel it when you fight that fall, like the floor pushing against your feet. This flips our intuition. Gravity doesn't make things fall, it defines what falling actually means. So what remains of gravity if falling makes it disappear? The secret isn't in one object, but in the relationship between two. Drop two spheres side by side toward the planet. In their own falling frames, they feel nothing. But from a distance, you see their paths aren't parallel. They both aim for the center. As they descend, the gap between them narrows. This relative shift, this tidal signature cannot be removed. It is the true mark of a gravity field. Gravity isn't about isolated objects. It is about how the natural straight paths of neighboring things are shaped by mass. To explain this, we need a new vocabulary. We need a law that defines the straightest path in any region. This rule must apply to rocks, moons, lasers, and time itself. In this view, mass doesn't emit a pull, it bends the geometry of space-time. Straight lines become the orbits we see. Light curves because the floor beneath it is curved. In a gravity well because time is woven into that fabric. This model is incredibly precise. It calculates Mercury's path, the flight of light, and the time shifts essential for your phone's GPS. Yet we must be honest. This is still a description, not a final why. We have math that takes mass as input and gives us curvature as output. We don't know why mass bends space. We don't know why every object follows those bends perfectly. The mystery of the cancelled masses remains. Gravity sits in a strange place. It is our most tested success. Yet our deepest philosophical puzzle. It isn't a thing that travels or pushes. It is a property of time and space emerging from mass. It rules the stars but ignores the quantum world. This isn't a lack of vision, but the edge of our map. The takeaway isn't just a mystery, but the value of intellectual rigor. Real clarity doesn't come from easy stories about pulling strings. It comes from the quiet collection of evidence and the grit to follow the math, even when it leads to a world we can't easily imagine. We may lack the why, but we have an incredible how. And in that how, crafted from data and logic, lies a superior kind of understanding, one that values the cosmos enough to hear what it is actually saying. If you enjoyed this journey through the fabric of space, please like the video and join us at Winds of Thought for more deep dives. The exploration of these fundamental truths is what drives our curiosity and expands our horizons. Every discovery leads to new questions, and every question brings us closer to the heart of the universe. In the grand tapestry of existence, gravity is but one thread, yet it is the one that holds everything together. We invite you to continue this journey with us, to look past the surface of the familiar and seek the extraordinary reality that lies beneath. Your support and engagement mean the world to us as we strive to bring these complex ideas to light in a way that resonates and inspires. The path to knowledge is a long one, but every step taken in the spirit of honest inquiry is a step worth taking. We hope this exploration has sparked a new way of looking at the world around you, from the simplest fall of a leaf to the grandest orbit of a galaxy. Thank you for being a part of this community, and for your shared passion for understanding the intricate beauty of the laws that govern our reality. Until next time, keep questioning, keep observing, and keep seeking the profound truths that wait to be discovered in the vast, silent reaches of space and time. Our shared journey is only beginning, and there is so much more to uncover together as we move forward into the unknown. The elegance of these scientific principles reflects the inherent order and complexity of our world, a testament to the power of human observation and the relentless pursuit of truth. Let us carry this spirit of inquiry into all areas of our lives, ever mindful of the layers of meaning hidden in plain sight. Each interaction with the world is an opportunity to learn, to grow, and to appreciate the wonders that surround us every day. As we move ahead, let us remain open to the surprises the universe has in store, ready to adapt our understanding and embrace the mystery that makes existence so rich and rewarding. The story of gravity is just the beginning of our quest to understand the infinite. Together, we will continue to explore the frontiers of science and philosophy, seeking clarity in the face of complexity and finding beauty in the most fundamental laws of nature. This collective effort to understand our place in the cosmos is a noble endeavor, one that unites us across time and space in a common goal. We look forward to sharing many more discoveries with you, and to hearing your thoughts and perspectives on the incredible phenomena we encounter along the way. Thank you for your curiosity and for joining us on this extraordinary voyage through the mind and the universe. The future of exploration is bright, and we are honored to have you with us as we navigate the mysteries of the great beyond.